Hello and welcome back to the Student Hub Live. Okay, this is the last of our evening sessions, sponsored by popular post-it note manufacturer and sellotape maker. No, it's not, sorry. But we're going to talk about the 3M's. So we've got lots of people here from the science department, and we're going to talk about moons, Mars and Mercury. Joining me in the studio are Simon Kelly, hello, Suzanne Schwesner and David Rothery. David, we've had some confusion from the quiz about Titan. Can you clear any of this up for us?
Titan is the largest moon of Saturn, with a dense atmosphere. I think some people may have seen a video about it just now. It has lakes of methane mixed with ethane on the surface, and it rains methane from the sky. Triton is the big moon of the planet Neptune, and it's got a polar cap of nitrogen ice.
Okay,
They're both
excellent.
Fascinating bodies.
Yes, no, well, there was some confusion there in the quiz, but we hope John Zanecki's video that we showed earlier has cleared some of that up for our panel at home. And well done in the quiz. You were very good. Where were you supposed to be last night, though? You were supposed to be at the quiz?
I was supposed to be a contestant in the quiz last night, but about lunchtime I was rung up by ITV News saying, can you come in the studio? There's a NASA press conference. NASA had put out a statement about 5 days ago saying we're holding a press conference, 7 o'clock British time, about surprising activity on Europa. Europa is one of the moons of Jupiter.
So you just dropped the Wheel of Ologies quiz off
I
like
dropped
a
the Wheel
shot.
of Ologies.
And what was the news all about then?
It wasn't sufficiently surprising or exciting for them to actually use the piece, sadly. But scientifically, it was good. Think of Europa, it's slightly smaller than our moon, with about 100 kilometres of ice mantling it, and the bottom of the ice is molten water. It's minus 160 degrees at the surface, but it's warm enough for water below. So you've got an ocean sandwiched between warm rock and cold ice, and we think there could be life there, hot springs on the ocean floor and so on, or things growing in the tidal cracks that open and close. So it's an exciting place. And back at the end of 2012, they found what looks like plumes erupting from it. But this is a view. The main picture is from a spacecraft close by, but a cluster of blue pixels at the bottom is from the Hubble Space Telescope, and the ultraviolet seeing a glow near the south pole of the planet, out in space.
How come they dropped this story then?
Well, this was what all we used to know about plumes. On one occasion, they saw this stuff erupting through the ice. Yeah. Last night, what NASA revealed was a different technique, and that's Europa in front of Jupiter, and there's some absorption of the light coming from Jupiter around it. There's 3 separate plumes erupting, so water gushing into space at 3 sites, and it's interpreted like this. Here you go. This is a cross-section of the outer part of Europa, somewhere near the South Pole. Here's the rocky interior, here's the ocean, here's the solid ice, and here's a crack through the ice, and water's jetting out into space. And if this is occurring, it's cheap and easy, relatively speaking, to go and sample that water and whatever's being thrown out with it. You don't have to land, just have to fly by, scoop it up, sniff at it.
Are these big cracks, Dave, that are opening and closing, or single volcanoes?
Well, we don't know. But all we've seen on the surface in quite high detail is cracks. You don't see vent like volcanoes, you see cracks. And there's a moon of Saturn called Enceladus, which has plumes erupting all the time. We have a spacecraft orbiting Saturn at the moment called Cassini, and it is seeing stuff erupting through crack-like features. So we're pretty sure now that Europa's like Enceladus, but it's not a surprise. These guys found what they were looking for. It was overhyped by NASA, basically, saying surprising activity.
NASA. Well, it sounds very interesting. And the thing about you guys is that you're always going to press conferences. There are always so many exciting things going on. And I think, students are saying, oh, we love studying space and we really want to go and do these things. And there are MOOCs and all sorts of things going on. But perhaps what they don't know is that the Open University are involved with a lot of missions, with developing a lot of instruments. Can you just give us a brief overview in terms of what the involvement is, broadly speaking, with some of these things going on?
The OU has been involved in missions for decades now. I was just thinking, relating to our moon, that what they're talking about doing with this is flying a spacecraft through a plume, which is in fact what they've already done on the moon.
Yes, we've impacted into the moon to throw up some dust and in fact water ice and flown through it.
Yeah. So the Open University is famously involved with the Beagle 2 mission, which was to Mars.
That was in this studio, in this
It was.
very space.
Yes.
We had to move it out, but,
Yeah.
but that's by the by.
Too many men in white suits. But more recently, we were involved in the Titan because John Zanecki, who was a professor here, was involved in the surface package that dropped onto Titan. It lasted, a few minutes?
It survived all the way through the atmosphere. It
Yeah.
lasted a couple of hours on the surface,
Okay.
I think, before the battery
But
ran out.
it measured the surface, it measured what was there, it took the pictures, so a very important piece of work. And the thing that was actually built by the OU scientists with the penetrometer, which actually told us something about what they were landing on. They wanted to know if they were going to land on creme brulee, in other words, something with a crisp surface and the soft underneath, or stones or
Very
whatever.
scientific.
They didn't know.
And don't get our audience on about cakes. They'll get terribly sidetracked.
Creme brulee is a very important concept. It's scientifically proven. It's a very important concept, the crust on the top. And you've got to get the crust right. Also, of course, more recently we've been involved in the Rosetta mission. So the instrument that was measuring organic molecules on the surface of a comet, again, Open University scientists, part of the same team. Several of the guys that I know who were part of the Beagle team were also working on Rosetta. We're now involved in Mars.
Trace gas orbiter?
The trace, I'm trying to remember the name of it. The trace gas orbiter, which is just about to start measuring methane in the atmosphere above Mars. And we're also involved in planning for a mission to actually go to the moon again.
Excellent. So lots and lots going on. And in fact, we have a Student Hub Live event on Mars at the end of October, which will be very, very interesting indeed. So Suzanne, tell us about then what's happening with Mars.
Well, Mars is a very interesting planet at the minute because we've got lots of orbiters around. Trace gas orbiter will arrive soon and start its mission. MAVEN has just started, which is also looking at the atmosphere of Mars. But then there are also 2 rovers active. One is the Opportunity rover, which has long outlived its lifetime because it was made for 90 days and over 10 years later it's still going. So that's pretty good. But there's also Curiosity, which is on the Martian surface since 6th of August 2012, and exploring Gale Crater. And we have found quite a bit of very interesting things there, including, of course, evidence for water, which is always very interesting if you look for a habitable environment. Ask the question, can anybody have lived there? Anybody always means microbes in that context. And also other questions about the Martian climate change and generally, how does Mars look today?
Excellent. Let's go to the hot desk and see what people at home are talking about. Sophie and Kate.
Yes, so as we expected, there's lots of chat going on. People seem really interested in this. I've had a couple of questions. One from Simon saying, what problems would we need to overcome to base humans permanently on the moon? And a related one from Sylvia about people going to Mars and whether it would be difficult for them to get back to Earth. So I don't know if anyone can answer those questions for our students.
I think we can take some of them. The main issue with being on the moon is, the first thing is getting to the moon. And strangely enough, the issue about that is how much water you can take to the moon. The moon has very little water, and so the big problem is actually getting from the Earth to the moon. We now know that there's water on the moon. So there is actually a really important resource, and you can use water in all sorts of ways, not just drink it, not just make ice cubes out of it. You can actually use it and break it down and use it as a fuel.
But do we know how much water?
In terms of...
Several Olympic swimming pools worth, which is not a lot, but plenty to drink if you recycle it all the time.
Yes.
Ah, OK.
Yes, there's a long discussion about the International Space Station and how many times they recycle the water and how it gets recycled, but you don't want to go there, probably.
No, we certainly don't. Not after what Libby told us today. She's hooked on the Student Hub Live and she's been taking her laptop all around the house, everywhere, even to the you-know-where. So we're not going to have any sort of discussion about toilets.
Yeah, but Mars is quite interesting in that sense as well, because you have additional problems. When you are on the moon, you still can see the Earth, and it's this beautiful blue marble in space. If you travel to Mars, our Earth would be a tiny dot of light, and we do not know what this does psychologically to people in that spacecraft.
There are some practical problems as well, because if you're going to be on the moon for any length of time, you either have to take all the buildings with you, or you have to build. So there is actually a guy in the Open University doing research on how you use a 3D printing system to print yourself a house.
Wow.
Print yourself a shelter using the moon rocks, the dust that's on the moon. The moon is covered in a very, very fine dust, which you can make stick together just by heating it. And so there's a system that you could use to actually print yourself a house.
It's very, very expensive to get stuff off the Earth. The Earth's got strong gravity. Get it from the Earth to the moon. You want to take as little as you can get away with. You need to use the resources that the moon provides. Otherwise, it's going to be prohibitively expensive.
I mean, our audience are having trouble getting to Comic-Con, which is the first mission they've decided to go on together. But still interested in travelling further afield, they are. But what is this obsession with people wanting to go and live on other planets? I mean, it's perfectly reasonable here, despite the whole climate change thing going on. Why is there this persistent idea that we should go and live somewhere else?
How long term do you want to think? We're all geologists.
Yeah.
I mean, I know that asteroids hit the Earth very, very rarely. I know that supervolcanoes erupt every 100,000 years or so. That's the likeliest thing to happen. You'll turn the sky black, you'll lose photosynthesis, you'll lose 1 or 2 growing seasons worth of crops. We won't go extinct at such an event, but would our civilization be robust enough to survive global famine for 2 years? You don't really want all your eggs in one basket. So we need to be self-sufficient somewhere else if we're serious about surviving as a technological situation in the long term.
And
Wow.
there's also that we are all natural explorers.
I think it's also what horizon, but when man wasn't flying, when man wasn't going to the moon, people went and climbed mountains. People went to extreme things. They explored the poles because it was the outer limits of where you could go to. That was it's humanity's desire to push beyond. Now we know we can reach the moon, so we're talking about how do we reach Mars, and then how do we do travel to other parts of the solar system, and then it's always what is the impossible thing that you can't do. So okay, let's go and try and do it.
Okay, but there's more to, I guess, what's going on in space than just the missions, because there's a lot of work being done on the instruments to measure things. So in addition to humans going, we're also trying to, as you say, research what's actually happening to see, I guess, what's viable in terms of potential planets or moons that we could look at inhabiting. The Open University are developing some really interesting instruments measuring things. Can you tell us a little bit about some of those and some of the rovers maybe that you mentioned as well? So things that are going on in terms of how we get things from here up into space and then what they're measuring.
Do you want to do rovers?
I could do rovers. I mean, Beagle was a lander. There are 2 different kinds of spacecrafts. There are landers that just have feet, and there are rovers. Simon is just holding one up. That's the Curiosity rover. That's the NASA rover, which is currently at Gale Crater. And the picture here is, so to say, a selfie. Look what I have just done. Because just down here, these little spots, they are the first scoops of soil that Curiosity took and sampled and analyzed to see what is the Martian soil looking like, what's in there. And we want to know this because the long goal of exploring Mars is to find out, could microbes or even more advanced life have lived on Mars? We know that Mars in its very early history was warmer and wetter because we know that there was water on the surface of Mars and that there was flowing water on the surface of Mars. Simon is doing a very good job here.
He is excellent, isn't he? Yes.
Because what you see here are rocks with lots of little round pebbles. And these round pebbles show us that the water was actually flowing on the surface, and we can count these pebbles and we can see how round they are actually. And so we found out that this stream that put these pebbles down there was about knee to hip deep and a fairly fast flowing little stream.
I can remember a few years ago when they first took the picture, I remember that Suzanne spent a whole weekend counting pebbles. It's very exciting.
Yeah, and that's because in a spacecraft you only get the picture.
Yeah.
If this were a stream on Earth, I would just go and I would take a scoop and I would sieve it and I would just weigh the different categories of gravels, because the distribution, how many big ones and how many small ones I have, tells me about this stream. How deep was it? How fast was it flowing? And so because I can't do that here, I needed to count them.
Let's go to the hot desk.
We've had loads of really good questions in, a lot about water actually, relating back to Mars. Kerry's asked, where did all the water on Mars go?
Good question.
That is a very, very good question, because part of the answer is we don't really know all of it. We know parts of the story, but we don't know all of it. Partially, parts of the atmosphere got lost, and in two ways. First of all, when the planet was hotter than it is today, and in the very early history, part of the atmosphere just got lost to space because the gases, the individual molecules would be fast enough to just leave the gravity of Mars. But by the time everything cooled down a little bit, that process has slowed down. We can still see it when we measure the isotopes, and that is what the trace gas orbiter is going to do.
It's difficult to imagine, but actually Mars is quite a lot smaller than Earth. I can't remember the exact dimensions, but it's half the size or smaller.
One third the gravity.
It's 1/3. Yeah, so you'd weigh less. You'd weigh 1/3 of your current weight if you were on the surface of Mars. That has an advantage.
That is a benefit, actually.
But it means that water molecules escape more easily from Mars than they do from Earth. So they escape more quickly, so it's dry. It's now incredibly dry.
Yeah.
Well, there's plenty of frozen water as ice in the polar caps and in the subsoil.
Yeah.
That is true too. So we have some that's locked up there, and you could unlock it if you heat it, for example, with a volcano, or when a big rock slumps into the surface and makes one of these craters that we observe on the surface of Mars, then you could unlock it for a while before it freezes again. But some of it also in these very big impact events could have just gone lost to space. So there are lots of processes, and we understand some of them, but unfortunately not all of them. And that's why we send things like...
I think the way that Mars history is described, the early part of Mars is described as wet.
Yeah.
I mean, there's different names for the different eras, and the first part describes it as a wet planet.
Yes, and the picture you just held up is from that early era.
The rocks are.
The rocks are,
Yeah.
Okay, let's take a look at Mercury then. Because we've been talking a bit about Mars and the Moon, and I know that you are very keen on the Moon's MOOC, which you're often plugging, aren't you?
I'm the educator on the Moon's
You
MOOC. Well,
are.
both Simon and Suzanne helped me write it, which is the Moon's
we're all
MOOC team.
involved in
Yeah.
it.
Yeah.
It was originally built.
But my research is mostly on the planet Mercury because I'm involved in the European Space Agency's mission to Mercury, which is called Bepi Colombo, which is launching in less than 2 years' time now. I'll get there in 2024 and start doing science. It's orbiting Mercury for at least a year, and if we're lucky, 3 or 4 years. But there has been a NASA mission there already. So here is what the NASA mission Messenger saw. This orbited for 4 years before it descended to the surface. And I've got 2 more views at progressively higher and higher resolution. It's an exaggerated colour here. It's not really this colourful, but you can see there's variation. This pale area here is the biggest impact basin on the planet. It's called the Caloris Basin. It's filled with lava. But the blue and the red areas outside are lava as well. It's a very volcanic planet. And it doesn't quite stack up because, as well as all the volcanic activity, there are lots of volatile elements. There's too much sulfur, there's sodium, there's potassium, there's stuff we don't know what it is, but we can tell it's mobile and volatile. It shouldn't be like that close to the sun, and we want to understand why. So if I just go to the edge of the Caloris impact basin and show you what it looks like. Well, here's the whole basin for a start, and there's some little red patches around the edge, which maybe the camera can pick up. When you go close into those, they're actually volcanic vents. That's a hole in the ground, which isn't an impact crater. It's not round enough. But it's been a volcano where there've been explosions at several different points sequentially, throwing out this red stuff across the surface, and there are more volcanic vents here. It's a weird place, and I'm writing a paper at the moment about how the blue lavas are cascading down a kind of waterfall, or they were cascading down a kind of waterfall from the high ground into the basin. It's got a very exciting history if you're a volcanologist like me. And there's loads of other things which don't stack up. And there's a British instrument going on, Bepi Colombo, which is built mostly by my colleagues at Leicester University. It's an X-ray spectrometer, and it's using X-rays to look at Mercury. It's not seeing through Mercury like when you break a bone. It's X-rays from the sun striking the surface and making Mercury fluoresce back in X-rays. And from the fluorescence, we can measure the abundances of several different elements at the surface. And we'll hopefully try and understand what it's made from and work out how it came to be like it is, because it just doesn't stack up. I've got a PhD student who's described this as the problem child of the solar system, which I think is a great phrase. Anybody
But you're
at home's
using-
got a problem child, they'll know what I'm talking about.
You're using so many different sources of information in terms of some of the instruments that are measuring things. And here you're talking, I guess, about a very, visual, pictorial, image that I guess you're getting from a NASA mission. How exciting is that when you get some of this data and then you're wildly speculating about what all of this could mean? I guess with a lot of other people in the global community. So what happens when you get some of this?
Well, you're quite right to suggest that it's many different kinds of information. This is like a colour photograph, and you can only go so far with that. There are measurements you take as well. You look at the different wavelengths of light and how they're reflected. You look at the magnetic field. You look at the X-rays fluorescing. You look at the thermal infrared coming off, which Messenger didn't do, but Bepi Colombo will. You look at the gravity. You look at the photography. You have to fit it all together. There's no one single instrument that will work it all out.
You're also getting elemental information. You know how much, the sort of roughly the amounts of iron and magnesium and things like that as well.
We know the elements which are there, and we know what minerals, what crystal structures they're bonded together in, and we know the grain size at the surface. And we try and measure as many properties as we can, because the data are always ambiguous somehow. But if you've got several independent lines of evidence, you can get a consistent story.
I was talking with Hazel Reimer last night about this, and I was asking her about the various sources that she measures, and asking her whether she'd like to go into space to look at volcanoes. She said no, but someone's got to do it.
Yeah.
And I was asking her about how she got into this, and Darren would like to know what inspires you. Which, incidentally, as I'm sure you're aware, she didn't really intend on being a volcanologist. She just somehow got into it. So, being in space, I mean, that's clearly a very glamorous job, going on the news all the time. What got you guys into it? Asks Davin.
I'm not a space scientist. I'm at heart a geologist. I'm interested in rocks, and I've been obsessed about rocks and understanding the Earth since I was very small. If you go back and look at my first ever school project when I was like 7, it's about volcanoes and about dinosaurs, and I picked up crystals and I picked up things on holiday, so I'm afraid I've been like this since I was very young.
Like many academic careers, it all seems very glamorous, but actually, deep at the heart of it, there's a lot of hard work and grafting, isn't there?
You've got to enjoy just the basic understanding. I mean, there's nothing as interesting as being the first person to pick up a rock and understand it and actually be able to interpret and say, actually, I know what happened here. I know what was happening when this rock was formed. Yeah. And it's the same as what Dave's doing with Mercury. You can look at that and you're saying, actually, no, I know what that means.
Or Suzanne, with the rounded pebbles on Mars, it's the same as a geologist does on the ground.
Absolutely.
You know that to move something that size, you can't blow it by wind. You know it's been transported and the corners have been knocked off. It has to be flowing water. It's just applying geology that we learn here on another planet.
So what got you into it, Dave, then?
Well, I wasn't a geologist as a lad. I wanted to be an astronomer. I borrowed every book I possibly could by Patrick Moore from the library. And I used to go out with my binoculars looking at stars and so on. And I went to university to do physics, but fell in love with geology. Well, also couldn't cope well enough with the maths that they require at Cambridge, to be honest.
Now we get to the bottom of it.
But geology is great, and you do need maths for a scientist, so carry on working hard at it. But I mean, physics, the maths they wanted me to do was ridiculous. So I became a geologist.
Yeah.
And it's great going out mapping an area, trying to understand. And I was able to go to Arabia and map part of Arabia using images from space to help me, which was great. And now the tables are turned, and I'm actually using satellites around other planets to do geology there. So I'm back in space. So I've had an interesting ride.
In a roundabout way.
Yeah, I enjoyed it.
Suzanne, what about you?
Well, I was mostly interested in analytics. I wanted to do chemistry, but in my year there were so many people that it was really hard to get a place in chemistry. And so I thought that mineralogy is actually inorganic chemistry, but there were very few people every year. And you got to work with all the fancy instruments, and because there were much less students, and the ratio of student to professor was much better for the student. And so I started mineralogy, and I really fell in love with analytics, with chemistry, with getting those numbers that help us understand these rocks. And when I was looking for a PhD, it was mainly the instrument about noble gases, measuring noble gases, which is a very rarely used technology that got me interested. Now, this came on Martian meteorites. That was the icing on the cake.
Okay, so it's all been a massive fluke, but some of our students, they will be saying, I want to be studying science. And Suzanne, you came and told us about some of the moon rocks, which I know Simon wants to talk about as well, and how we're using the virtual microscope to actually allow students, and in fact anybody, to have a look at some of these and to make measurements and to collate data. So this is an exciting way that we're, I guess, enabling people to study and to get a piece of space. Could you tell us a bit about that? Simon?
Yeah. We've been talking about looking at things at a distance and what you can do. There's absolutely no substitute for getting something in your hand. So you may not be able to focus on it, but I'm just going to, there's a very thin piece of glass, and on that, stuck to the surface of that very thin piece of glass, is a rock which is ground so thin you can see through it. Suzanne,
No, I was just.
you can hold that one. So that's a larger one where you can see writing through it.
But yours is from Mars.
This is a piece of Mars.
Wow.
So what I'm holding there is not a moon rock, it's a piece of Mars.
How did you get that?
It's a meteorite. So there are a class of meteorites, we'll come back to that, I promise.
Yes.
There's a class of meteorites which we know are from Mars, several classes of meteorites. The point of showing this is that this is a thin section, this is how we study rocks as a standard. And on the virtual microscope, so you can hold that one. So on this website, we've created for students to use to look at rocks. And the wonderful thing about digitizing these images, which are just pictures of these very thin sections with light shining through, you can discover and understand all sorts of things about rocks. But you can do that from rocks from Earth, but you can do that rocks from the moon. The difference between Mercury and Mars and the moon is on the moon, we've been there. People have been up there. Apollo 11 landed in 1969 in July. They jumped out of the pod. One small step for man, giant leap for mankind kind of stuff. They were on the surface for a whole 2.5 hours. And in that time, they collected about 40 rocks. NASA still have those rocks. And so what the Open University's been doing is working with NASA to digitize the images of those thin sections. So lots of little things like this. And
they are beautiful, aren't they, these?
When you look at them in different light conditions, you get these rather beautiful pictures. And some of the students watching are maybe thinking about earth sciences. Some may be thinking about all sorts of different subjects. But these images are just beautiful from the colours, from the shapes, from the textures. And I think you can appreciate the beauty in these without actually needing to understand them.
Yeah, no, absolutely. I mean, aside from making a nice screensaver, what would be the point of going? Which is my automatic.
Been there, done that.
Yeah. What would be the point of going and looking at some of these things? What might people be measuring or looking for?
With something like that, you can measure crystal sizes because the virtual microscope has a built-in measuring. You can understand what crystals are. Dave was talking about sorts of minerals that you get on Mars. Well, you can tell looking at a rock like that. You look at it and you might see beautiful blues and oranges, and I see pyroxene and I see plagioclase minerals because I know how to recognize those minerals. Right. And when the guys jumped out on Apollo 11, there are two types of rock. There's this kind of rock, which is a smashed up mess of rock that's been pulverized and melted and remelted, and if you go on the virtual microscope, you'll see lots of these. There are basically two types of rock in the Apollo 11 collection, these smashed up ones and beautiful basalts like that. So that's a lava flow. This is a lava flow that's been broken many, many times by meteorite impacts.
So with these meteorites then, how do you know where they're from?
These were collected on the moon, so these are we know where they come from because we collected them. So I'm going to let Suzanne talk about Martian meteorites. That's called passing the buck.
Yes. No, the Martian meteorites we had in our collections long before we knew they were from Mars. And it took the Viking spacecraft in 1976 to land on Mars and measure the Martian atmosphere. And in Simon's picture, you saw that black. That black is actually glass that is happening when a rock smashes into a planetary or lunar surface. And on Mars, when there is also the atmosphere around, you press this atmosphere into this glass, and the meteorite that then flies off Mars and comes here will have a piece of this glass. And in this glass, we found the Martian atmosphere. And because the Martian atmosphere is very special, now I come back to the noble gases that I did for my PhD. There is the noble gas xenon, and that has a very, very special composition, the isotopes, for those who have still remember their chemistry A levels. The isotopes of xenon are very special in the Martian atmosphere. And we found that very same call it a fingerprint, that Vikings saw on Mars in the atmosphere in these meteorites, and that actually connected the two.
Oh, OK. So, Stuart, it's a little bit more complicated than having Made on Mars on the back of it, I'm afraid. And it takes a specialist, I guess, to do it. Dave, can we have a final word from you?
Well, I can talk a little bit about water on Mars, if you like, because here we have Mars, and here we have some water on Mars, and you saw it here first. No,
this is terrible. This is not on. Not on at all.
Water on Mars keeps being discovered. It's a bit of a joke because when the first spacecraft went there, they saw craters, but subsequent spacecraft saw channels carved by flowing water, valley networks. Oh, there's water on Mars. And then you find that the polar caps have water in. And then you find gullies which appear to be formed by flowing water. Then you find minerals which have been hydrated. And then you find little damp patches that seep down the slopes. We found water on Mars. How many times?
There's also the scoop.
15 or
Do you remember
20?
the scoop that scooped up and there was ice just under the surface?
Absolutely.
So that's again
Yes.
water on Mars.
Yeah,
Yes.
we found water on Mars many
At least
times.
half a dozen times.
People are now saying we're going to find plumes on Europa time after time after time. The way NASA are hyping it, it's the new water on Mars, the plumes on Europa.
OK, so we've talked about some various things, this obsession with finding water and life, but Mars and Mercury and the Moon, I mean, what's really exciting? We've got another Student Hub Live on Mars at the end of October. So if you'd like to know about that, press the Count Me In button on the website and give us your email address and we'll keep you up to speed with when that's happening. What's the next big thing that we know about or that we can predict, I guess?
For each of them, on the Moon, the next big thing is we are sending probes to the poles of the Moon. The reason for that is the poles of the Moon, we know, have water. And it's a unique place on the Moon, maybe in the solar system. Very, very cold, but we know there's water on the Moon at the poles. So we are actually developing a mission which is going to go to the poles and measure that water to see what sort of water it is. Is it water like is on the Earth, or is it water that's from a different source?
But also watch out for some Chinese manned landings on the Moon in the next 5 years, maybe. It won't be at the poles, but they'll go somewhere where Apollo didn't, for sure.
OK. And what about Mercury?
Mercury, well, it's almost it's an 8-year wait till we get there, but it's a planet which isn't right. We don't understand it. Where did it begin? Did it begin further out and bounce off Venus on its way in? We don't know. There's a lot more to
So right
to
at the
find
start
out.
of that journey in terms of discovering.
Yeah.
And Mars.
We don't have to wait 8 years. We've got the Trace Gas Orbiter arriving very soon. And then in 2020, there is ExoMars, another rover. And that will do something super interesting. It will attempt to drill 2 meters deep. And that's because around Mars, there is a lot of radiation that would destroy any organic material. So if we want to study organic material, we need to get below that irradiated outer surface. And that's what ExoMars is going to do.
Excellent. Thank you very much. Well, Dave, Suzanne and Simon, thank you so much for joining me. And as I've said before, you know, we're going to have a Student Hub Live special in October, all about Mars. So join us for that, where there'll be lots more space discussion. Sophie and Kate, how's everything there?
Really good. There were loads of questions and we're really sorry if we didn't get a chance to get through all of them. There's a lot of discussions on water, parallel universes. Kerry is eating Jaffa cakes made with lime. Apparently they've come from her parallel universe. So
Does she make them?
I don't think so. Back to our biscuit discussion as always, or cake discussion. Sorry, McVitie's. So yes, that it's all gone really well, and thank you ever so much for joining us. It's been a pleasure this afternoon. Thank you.
Yeah, it's great. And of course, lots of people are saying, oh, is Student Hub Live not just a Freshers Week thing? So just to, restate what you've just said, Karen, that there'll be lots more events coming throughout the year, and that you should click on the Count Me In button if you want to be kept informed.
Excellent plug, Kate. No, that's absolutely right. So thank you for that. Yes, no, we have a lot of events for the Student Hub Live. And in fact, you can catch up on some of them. So when something big happens, like the Olympics and the referendum and things landing on Mars, we like to have a Student Hub event about them. And this Freshers Week is just but one of many activities that we can have that you can join in. So if, like Davin and Ben, you like coming along to all of them, and we do appreciate that, then please do click on the Count Me In button. As Kate says, give us your address, your email address, and we will make sure that we keep you up to date with when we've got more events on. All right, well, that's all we have time for tonight, I'm afraid. It's been a really, really brilliant day, and we're going to come back tomorrow because we like to do that. And On Thursday, we have a special event as well for the Faculty of Business and Law. So the Law School and the Open University Business School. We're going to be holding a special event for freshers there, but we also have a lot of activities then as well. We're going to be having a moot and doing all sorts of interesting things that anybody can come to. But tomorrow we're back for our Freshers' Fair, and again we have a packed day for you from 11 o'clock. The chat will open at 10:30. So I do hope you can enjoy it. If you haven't been able to watch all of it, it is available on Catch Up, as are the boot camps, which we've been running over the last few weeks on a Monday. And those have been about getting yourself ready to start studying. We've been doing all sorts of things like time management. In fact, Suzanne did a session on that. Reading and note-taking, essay writing, the virtual learning environment, how to submit a TMA, assessment, how to deal with feedback. So all sorts of really, really useful things that you can tap into if you have time. And we're going to go home. We're going to have a break, but do keep chatting. The chat room will be open for another 20 minutes or so. So please feel free to say your goodbyes. We'll show a short video after this just to wind down. But from us at the Student Hub Live, that's all for tonight. I hope you can come back tomorrow. Do click on the feedback button as well and tell us what you thought of the show. And you can always email us any thoughts, any selfies at studenthub@open.ac.uk. Bye for now. See you tomorrow.